Been a little scheduling change today. Greg had a last-minute issue come up. Had to unfortunately cancel the Neo4j session. I'm standing in. We're going to do a session on introduction to big data. We're going to look at Hadoop and the different ways you can deploy it into your environment. Some of the pieces that make up Hadoop and the architecture. Different, excuse me, different scenarios where you would want to deploy. Pardon me. And then also looking at different areas. Do you want to deploy on premises? Cloud. If you're in the cloud, do you want to go to platforms or do you want to go into virtual machines? That was the weirdest thing, by the way. So a little bit about me, so you don't think I'm just some crazy guy they just pulled in off of the beaches area to come in and speak. My name is Josh Luedeman. If you're from the Jacksonville area, you're familiar with the company. I work with Pragmatic Works. Who doesn't know who Pragmatic Works is? Okay. We're a local BI consultant company out of the Orange Park, Middleburg area, headquartered. We work nationally, consulting on business intelligence, cloud architecture, SQL Server, basically focusing on Microsoft stack itself. I'm also speaking this year at the PASS Summit. If you're familiar with PASS, or if you're not, it's a professional association of SQL Server professionals. I'm doing a pre-con with Bradley Ball on optimizing your data in exactly this space, talking about the new data warehouse. Everybody knows their data warehouse and dimensions and facts. The data warehouse has been evolving with the onset of big data. And the session we go into is just kind of how that evolution is going and what that looks like. So for what we're going to go over today is just big data basics, basic introduction to big data. What is it? What is that huge term that IBM started putting out in their marketing, where everybody has their boss come into their office and they're like, I want big data. And then when you ask them, well, tell me, what is it? I have no clue, but I want it. It's like the cloud commercials. How many people remember the IBM cloud commercials? Everybody was like, oh, we got to go to the cloud. We got to go to the cloud. For probably the first, what do you say, Hervé, 6 months maybe that those commercials were out? You asked any IT boss, director, VP, CIO, what is the cloud? I have no clue, but we need it. Okay? Same idea is going on, even to a certain extent still with big data. We need it. Why? Because there were those cool commercials that talked about big data and analytics. I don't really know what all I'm going to get out of it, but I need it. They said I do. So we're going to go over, what is big data? What does it look like? Okay? Big data makes you think one certain thing. It's data and it's big, right? Not really. It's different data. It's not big data. What do I need? So what kind of tools do I need to work with it? And then the new and the old. So what is it? The name is totally misleading. Size has no relevance to big data. Okay? It's complex data. Now complexity could be in sheer volume, can also be an organization. How many people got an email today? Come on. You got to be kidding me. I got 7 emails from Old Navy today. Okay? That's big data. Okay? It's semi-structured data. Text documents, emails, reports. And when I say reports, I don't mean your nice tabular report. A report that someone spent like 8 hours, for me as a consultant, an infrastructure assessment that I've done for a client. Technically, that's big data. It's not column delimited, separated values like we're traditionally seeing in a relational database. Okay? Where size does come into play as big data is for difficult problems, where you need to take advantage of distributed computing, whether it is because you have to make sense out of semi-structured data like emails and things like that, or whether it is just sheer volume of data. You need to distribute the workload. Big data is not just Hadoop. How many people walking into this session thought big data, that's Hadoop? Be honest. I did too when I looked at big data. I'm like, oh, that's Hadoop. It's a marketing guy's got a hold of Hadoop, said, oh, we don't want to dangle an elephant in front of people. Let's give it a cool name. Well, not really. Because big data also touches on technologies, other technologies that, like NoSQL, which doesn't mean absolutely NoSQL, by the way. Everybody thought that too. It's NoSQL. That means NoSQL. It means no more select, no more from. Woohoo! No, not only SQL. Okay? Because then with that, you're going to have some of them that can integrate in with semi-structured data with structured data. There's a lot of different cool things. Document databases. Okay? All kinds of fun things in memory. MongoDB. How many people have a web app with session state in SQL Server? It's okay. I will not judge. Okay, let me take that back. On that one, I will judge. Session state in SQL Server is terrible. How many people have ever seen it where somebody else did it? How many people thought it was really a good idea? Yeah, I know better than that land. Session state is terrible because it's moving like that, okay? MongoDB, great option for customers that I had talked with over the years that said, you know, we're running session state in SQL Server. We think it might be hampering our performance of our application slightly. Slightly. MongoDB takes that highly fast and transactional nature of getting session state in and out, puts it into memory. All of a sudden, performance on that's not a problem. That is technically a big data product. So why did big data come to be? Well, it was the rise in need, and I love that statement because it sounds so business-like, right? The rise in need to combine unrelated data. English, please. Here's a great business case example of that. There is a certain company that distributes weather information on the internet and television. I won't name them. Okay? They came to a consulting company with a business problem. Their problem was, hey, we put out all these ads on weather, you know, on our different pages that we service, you know, weather internationally, okay? And we want to put our most expensive ads, our eBay, our Amazon, and we want to put it on the pages that are getting the most traffic at that time. And since we have all this data about where we're getting the most traffic, and we have data about all our forecasts and where the weather's the worst, there's got to be a way to do this. Hadoop. They used a Hadoop cluster, I can't even remember how many nodes, to comb through the current conditions, forecasted conditions globally, both of those are globally, and all of the web access logs of every single server in their web farm. Now, everybody in this room knows who I'm talking about, knows how many servers are most likely in that farm. That was huge. They brought it together and started shifting the ads with the current conditions and the forecast. So if you were living in the middle of in the Midwest, Kansas or something like that, you had forecasted today that there's probably going to be some tornadoes popping up. You were seeing a lot of eBay and Amazon and who knows, maybe a couple jewelry store ads all over your weather pages. They had a dramatic increase in revenue, double-digit percentages increase in ad revenue just from implementing that solution. Being able to just read through the logs, say, okay, well, this area is getting a lot of traffic. Let's shift some of them. The weather's really terrible here, and it's going to get worse. Let's shift them all over there. And we'll put Joe's Mechanic Shop over out in LA where it's still sunny and, you know, everything's fine. Okay? The changing characteristics of data. Okay? What does that mean? Okay, so there's some companies that operate windmills, okay? Not your farmer's wood windmill, the nice, really future energy type windmills, large metal ones. Have anybody seen those before? I mean, half a blade takes an entire 18-wheeler to take it to the site. Okay, they're huge. Before the onset of using Hadoop technologies and big data technologies, those windmills were just maintained regularly. Okay, they'd have a maintenance schedule of, I don't really know for sure, but we'll say 6 months. Every 6 months you go out and have a mechanic take a look at it, make sure the bearings are all good, there's no issues, that sort of thing. Otherwise, if a windmill goes down, power output stops, you send out a mechanic to handle it, right? There's a company that operates, one of the larger operators of windmills in the country. Okay, and they set up a Hadoop cluster that actually would pull maintenance data off of every single windmill they owned. Okay, they were pulling speeds compared to wind speed and looking at the variance along with a bunch of other sensors and metrics within the windmills, and would actually predict based off of that data when it was going to fail and send out a mechanic 2 weeks ahead of time. Now you wonder, why would you do that? Okay, windmill goes down, you're looking at probably at least a month it's down without knowing it's going down, right? You've got to take about a week, you've got to find a mechanic that's going to go out, you've got to get him out there to diagnose the problem, then you've got to order a part, and then he's got to come back and put it in, he or she, right? By being able to predict that, what was going to happen or when it was going to go down, you are now at least slashing that in half. 50% increase in profit. You know, you're only down half the time you were. Okay? A lot of it too is coming into line with analytics requirements. How many people have shopped online? Come on, thank you. I'm all about audience participation, so I ask ridiculous questions like that so that when you don't raise your hand and you're at a technical conference, I can go, ha ha! Okay? How many people have shopped and it says, when you click on an item, it says, people who added this to their cart also bought this? Market basket analysis. Done by predictive modeling, okay? Using big data technologies. Now, big data has become so huge that it's lumping in older technologies like R. How many people have heard of R as a programming language? Great. R is a mathematical language, basically. I used R in the 90s. It's built on C, and it was used, I used it in calculus classes. You can plot with it. You can also get libraries to go into it and actually do machine learning algorithms, design them. I've done a couple of them, and in fact, as part of this session or my other session, I'll be tweeting out later today zip files for both of these sessions. I'll throw in a quick R script that does just a basic regression model you guys can run. So it was a lot of that coming into play. Market basket analysis is probably one of the biggest ones. If you've used Netflix, you played one movie, and when you first create your Netflix account, it asks you, click these movies that you like. It creates a predictive model to say, well, he liked Batman, he liked Superman, he liked Iron Man. I think he's going to like RoboCop. He's probably going to like, you know, whatever, Guardians of the Galaxy, you know, all these movies. And it creates predictive models. Makes a better user experience for me when I'm on Netflix that it doesn't start popping up My Little Pony. You know? Well, it does do that. That's every once in a while my daughter gets a hold of my account. She clicks the wrong profile. I had to reset my profile after they finally created separate profiles. I reset mine because I had like Handy Manny, Mickey Mouse. I'm like, oh, this is crazy. Another thing that's influencing it is the decision making anymore. How many people have a boss that makes a decision without seeing numbers? I want your boss. Really? Really? I'm really shocked by that. There's so much of higher leadership, of executive leadership, and the decisions they make at a company are more and more based on numbers. Marketing uses, to this day, uses more Twitter and Facebook and what people think of them, of organizations, than they ever have before. This has given them the ability to do that more so than ever. So, come on, analytics, big data, data science, business intelligence, it's all the same, right? I mean, come on, you're a BI consultant talking to me about big data right there. It's not all the same. There's different ways to cut it. Business intelligence, and the easiest way when I was first learning about big data, how I had it identified to me, business intelligence is the analysis of the now and the yesterday, okay? It's what's going on now. How many people hit their data warehouse for today's numbers against last year's numbers, against the year before's numbers, right? Big data takes it to the next level and says, what are we looking at tomorrow, 5 years from now? What are we crunching numbers that maybe you couldn't do to check the history of 20 years worth of sales if you've got them digitized? You couldn't query those numbers with a data warehouse very easily, could you? Not if you're a large company. You have these opportunities now with distributed technologies. So what does this mean for your job, okay? A lot of people, business intelligence developers, architects, DBAs, they're like, oh crap, here we go again. Something new, something way off base. What does this mean for me? It means there's another mouth to feed, okay? When I say that, you have your web boxes, your web servers, okay, that are sucking off resources. You have your networking team, your phones team, your server team, your SQL server, your cloud team, all of those. Big data is another piece of the puzzle, okay? From the standpoint of a BI developer, if you're a business intelligence developer and you're in this room right now, if you don't at least look into this technology, you will be left behind. I mean, we've already half sold out, or at least, actually no, not for this session. When my session that I'm doing at Summit was done earlier this year at a conference called BITS in London. Anybody heard of BITS? Okay. When this session was done in London at BITS earlier this year, it sold out about integrating big data with your data warehouse. It's coming. It's already, in a lot of ways, it's already there. I've worked with a couple clients specifically in the utilities space, wanting to predict what their customers are going to be using for utilities so that they can plan now expenditures to expand their footprint to be able to handle that amount of energy traveling through their network. Okay? It's coming. Application developers, at least start to look at or refresh your skills in Java in some cases. But don't worry so much about Java either. If you don't have Java, don't freak out and go buy $300 worth of books and sign up for $4,000 worth of training and then blame it on me. Don't. Okay? Because some of the tools I'm going to go over here in the next slides, they actually bridge the gap. They're high-level languages that run over top. It writes all of it for you. Okay? Like Pig. Pig. Oh, okay, before we even go down this road, you can laugh as much as you want about the different modules that are part of the Hadoop ecosystem. Okay? I do all the time. Because the names are just crazy ridiculous. Hive. You think of a beehive? Well, their mascot is a bee, as a matter of fact. Hive is your querying language. Okay? So you have maybe, I know I said, semi-structured data, but maybe for this specific example to talk about Hive, you have petabytes of CSV files. Petabytes. Hive gives you the ability to put a table-like metadata structure over top of your files, so then you can write SQL-like queries to read the data out. For me, I know no Java, absolutely none, okay? I love Hive. I can write select distinct product from sales, you know, or something like that, and get my list of products that exist in that entire file system. Pig, terrible name again. The only thing worse than the name Pig is the name of the language used by Pig, Pig Latin. Yes, please laugh at that. If you don't laugh at that, I fear for you. That is hilarious. They went to that level. Pig, their little mascot and their logo, kind of obvious. It's an ETL language. How many people have heard of SQL Server Integration Services? Same thing, just command line based, okay? And it's literally as ridiculously easy as Pig Latin. Ig, pay, atin, lay. I mean, it's load, you know, variable A equals load file path. I think we can all write that. If we've done any kind of pseudocode at some point, you can write Pig. Hcatalog handles all the metadata, okay, around the files, their structures, things like that. HBase is non-relational databases. So it's, you know, it's kind of in that category, though it's not the same thing as Mongo. There's all kinds of other projects that are, again, part of the Hadoop ecosystem. Zookeeper, Oozie, handling job scheduling and job handling. If a job fails, those handle that. Embari. For a guy who started out with Hadoop when the versions were in 0 and 1, Embari, if it was a real person, they'd probably already own a car from me, okay? Embari is management, cluster management, okay? If you try and stand up a Hadoop server strictly off of the base Apache code, you're going to be busy a while. You're very busy for a while. Embari, you either open up all the ports on the server or install the agent on there so that it can communicate with the head node. And you log into Embari and you say, deploy Hadoop to this server. Click, walk away. Have a good day. You can set up deployment templates and deploy servers as you need. Wonderful tool. There's other projects out there with Storm, Spark. Basically what those are doing is those are speeding up the data that it can receive and handle, okay? Because for the longest time, MapReduce was the main engine of Hadoop, okay? MapReduce handled checking your cluster, whether or not your nodes were up. It handled the actual work. MapReduce did everything. MapReduce is a system architect's worst nightmare because it is your single point of failure on version 1 and before Hadoop. MapReduce crashed, you are in trouble. Rebooting the server hopefully would fix it. If MapReduce somehow in the source files got corrupted, you weren't going anywhere. MapReduce did everything. Then we said, or Apache said, okay, you know, there was a big movement after version 1. Basically, they started doing some bugs, and they said, you know what, we need to get rid of this because enterprise adoption is not going to happen with a single point of failure. If everything dies with MapReduce, we're all dead. So they went with Hadoop 2.0, and they said, all right, we'll keep MapReduce on here for larger batch jobs because you can't beat it. MapReduce splits out the data to multiple nodes within a cluster, multiple copies, splits out the work as well. You can't beat that for large, enormous batch processing, okay? But we're going to add in Tez and Yarn. Basically what they did is they took MapReduce and split its work in half. Tez handles the execution side of the business. Yarn handles all the cluster resource management. Pinging out there to the cluster. If all you guys are in my cluster, you awake? Okay. You awake? Okay. Yeah. MapReduce was doing that too. By splitting it out, and like they did with Windows when they finally got rid of Vista and the old 3.1 architecture and went to Windows 7 and rewrote a lot of the base code, they did the same thing here. By going to Yarn and Tez, all these services got faster because the code was updated. It wasn't still the same base MapReduce code in a lot of ways that helped get Google started and Yahoo. Okay? That's where this technology came from, was from Yahoo. Search engine work. Okay? By updating the architecture, now we've got more speed. So how does a cluster work? So I walk in to my, to my cluster, up to my client, and I'm like, okay, I want to upload a file into my Hadoop file system. So I upload it, and the first thing to do, it goes to the name node. And the name node says, okay, I'm going to break your file up into 3 pieces. I'm going to put the first piece of the first copy, the second node of the first rack. Okay? Yes, our servers or our racks should have more than 3 servers, but let's keep it simple. Now the second piece of the file is going to go on the first node of the first rack, and I'm going to put a copy of the first piece, second copy on the third rack, third node, and so on. So that you're distributing out the files. Now, obviously, as a data guy, I want my files, multiple copies of them. Why? No single point of failure, right? That way, if I lose one node, I don't necessarily lose the whole file. In fact, with this structure, I don't necessarily lose any piece of the file, because I've got 3 copies of 3 pieces of the same file distributed, right? One node goes offline, say node 2 goes offline, the name node gets that through Yarn with version 2, says, okay, copy 2, section 2, and copy 1, section 1 are offline. I need them to now point to this copy here and this copy here. And now I'm going to redistribute those 2 copies that I had there over to this node, which doesn't have anything on it. Okay? It's that redundant ability. The reason you have the 3 sections of the file isn't necessarily so that you have multiple copies and no single point of failure, but now you get a second benefit. Now when you send that query through Hive to get your distinct products, the name node takes the work and says, okay, you work on the second section part, run this query. You work on the first section part, you work on the third section. Once you guys collect all your data, send it to me. I'll handle massaging it together at the last part and send it up. So now we've got a lot of hands in the pot. Okay? So when you talk about Hadoop, you've got Apache versions. Okay? Hadoop is open source. Okay? It's an open source project, which means it has its own version numbers. Hortonworks, one of the main vendors of Hadoop in the space outside of open source, so they sell their own distribution of Hadoop with a level of support and also their own applications. More so the support for them. Their revenue model is based around, we're going to sell you our support to help you run Hadoop. Okay? And training. More on that lines. Then you also have Cloudera. Cloudera says, yeah, we'll give you some of that, but we're going to really build you some awesome tools that's going to work with Hadoop and make your environment, your data management. They have some great tools that'll even tell you how your data is being queried. So you can actually housekeep on your cluster. If no one's looking at your marketing data, which is insane, but it was just the first department that popped in my head. If no one's querying your marketing data, why do you want it out there in your cluster, taking up space? You don't. You get rid of it, right? Cloudera has some great tools with some of the acquisitions they've done over the last year that they can actually, it actually keeps track of how your data is queried and tells you better ways to organize it. Maybe it'll find that someone, whenever they're, people, whenever they're querying your sales data, they're always aggregating it. They're never getting to the detail level. So if you created a Hive table that was just the aggregations of the data, that would work great. Cuts down on traffic. Make sure your cluster more efficient. Okay? But anyways, the version numbers get complicated because, say, Hadoop 2.1, that might map to Hortonworks 2.4, okay, which maps to TES 0.4. If you ask me what version you're on, or tell me what version you're on and I'm supposed to help you, it's not going to happen. Not without a Google search. Don't try and make it happen. You will drive yourself insane. Okay? So the cloud. We got to go from one buzz term to the next, right? How does that in big data coming together? So the cloud is actually opening up a lot of avenues. There's, specifically with Azure, you have a cloud platform now called HD Insight. So HD Insight runs Hadoop, as well as HBase, as well as Spark. Okay? So that you can run a platform and not have to worry about paying all those hundreds of dollars a month for each node of your cluster to be running in VMs, right? The platform, if you only need a cluster for a few hours a day, HD Insight's great. You spin it up, you have your data already stored in blob storage, you spin up your cluster to be over top of that blob storage container and account, run whatever processing on that large volume of data or complex data, run your processing, spit out any output, turn your cluster off. You're just billed for, I believe in some cases it's like maybe $1 or $2 an hour, depending on how many nodes. I mean, obviously it's, you put faster, higher resource nodes out there and more nodes, obviously you're going to get charged more per hour, but you're able to do it on a budget. Interesting story about doing it on a budget with HD Insight. Everybody familiar with the New York Times, I believe? Okay. They went out there and digitized years of the New York Times in a weekend. Pretty cool, using HD Insight. But the cool factor for me that sent it over the top, they did it on a credit card. Okay? I've been in so many discussions about architecture, purchasing discussions that take months to deploy large architectures to do things that aren't even as complicated as that. Okay? Huge expenditures. Anybody priced a server lately? Okay? They did all of that work on a credit card in a weekend. Digitized it all. That is amazing. Okay? The cloud is allowing everybody from Joe Schmo to Fortune 500 to be able to do the work they need to do utilizing Hadoop at a value. Okay? Now the cloud platform model isn't for everybody. I've worked with clients that have a 24-hour need to have that cluster running and queryable. The cloud platforms might not necessarily still be a viable option for you, okay? And those are some of the cases where you need to look at maybe running it in virtual machines in the cloud, if you still want to be in the cloud. I had one client that I worked with, they had no infrastructure in their office. I walked into their office, they were on a second floor of a small, very small office building. It was up in the Northeast, so it looked like it was actually a large house that had been converted into office space. They had no server room. The only infrastructure they had in the building were the laptops and workstations they worked on. I asked them, I said, would you guys ever be interested in it? Because some of their data problems didn't necessarily need to be solved by Hadoop, but they were prospective clients for an APS solution or massive parallel processing version of SQL Server. I said, would you guys be open? You know, you got to have some kind of server. No, we don't. We have no server room and we will never. I said, okay. That's when you look at infrastructure VMs, okay? Run it in virtual machines outside of your environment. Even in some cases, that's not necessarily going to work for a multitude of reasons. I mean, you can talk through pieces about the sheer size of virtual machines you would need to run it on each node of the cluster, that it may not still be a viable option for you to be able to do because of cost. Then that's when you want to look at on-premises. I tend to make on-premises, when I'm talking to clients about architecture, one of the last options, because of the amount of the cost of monthly upkeep of power, sysadmins, you know, server engineers, whatever, and then also the upfront investment of buying that size architecture. Because if you have a legitimate business need, you're not going to go out there and buy 5 servers to run a 5-node cluster. If you have to go outside of the cloud, you're in double digits minimum of nodes. Okay? So Yarn and Stinger versus MapReduce. Yarn and Stinger do the same things MapReduce did along with Tez. They do them faster, and it eliminates the single point of failure, just like we talked about before. The ecosystem itself, Hadoop is not a database. It's a file system, HDFS. Okay? It's a distributed file system. That's it. Any of the database type tools you see, they're not Hadoop itself. They're part of the Hadoop ecosystem, as I call it, but it's not Hadoop. At its core, if you want to be a jerk to someone and they say, we're going to go query Hadoop, well, no, actually, technically, you're not going to query Hadoop. Hadoop is actually a file system. Just to throw that out there for you, okay? And also, when I go to talk to people and they say, I say, do you know big data or anything like that? You know, I'm talking to them about a problem. Oh yeah, Hadoop, I know all about Hadoop. Yeah, it's a great database system. No, it's just a file system. So the Hadoop puzzle, we talked about this a little bit already, but I like to throw multiple pictures here in this because it gets confusing. If you can actually keep up with all of the pieces of the Hadoop ecosystem, you're awesome. Pig and Hive, those are most likely what you are going to run into with just basic data analytics. Just looking at loading and pulling data. Hive and Pig. Ambari, Falcon, Uzi, those are all around the operational, the management side. If you're a server admin, you'll get to know those guys really well. MapReduce, Tez, and Yarn. If you become a big data architect, you'll know them in and out. It's easy as that.
Does Spark play into those?
Spark is one of the pieces in here as well. But as part of these pictures, these are slightly outdated. Spark was still a pipe dream not a pipe dream. It wasn't, Hortonworks wasn't ready to distribute it when this diagram was out. But that would fall into the Pig, Hive, HBase area. So we talked about Hive. It is truly a comfort zone of SQL Server, BI, any database folks. I can go out there without having to know how to write Java code or any kind of be a developer of any kind, just a data guy, and I can go out there, select my data, insert into Hive tables, or I can set up tables quick as anything because it's schema on read. I can create tables over top of existing data files, and then it's collected and organized into that schema as I select it. So you can create a table. Whenever you write a create table statement, especially an external one in Hive, it executes real quick. That select statement, though, that takes a while. If you have a good system, if you have a large data or complex data set. But the Hive QL, or that's our SQL-like language, that's going to be converted into MapReduce jobs or Spark jobs, Tez, whatever, depending on the statement you're writing. I believe Hive is fully converted at this point, but still, I like to say at one point there was some that was running MapReduce still, but for the most part, I believe Hive is converted. It's metadata. Data storage in Hive, all the data is not in a database, okay? It's still stored in files. Even if you create a regular Hive table, which is an external data store, that is still data in files. They're stored in text files. RC files, I believe. The tables in Hive are just metadata maps. It's just pointers for developers. It's just pointers. Select, product from, and then when you do select product from sales, the metadata structure says it's the third column over in this folder, any file that meets this naming structure. Go find it. As part of the Hadoop ecosystem, there's analytics products that you can use today to actually get hold of the data. Okay? This is where a lot of the power comes in anymore. To be able to run machine learning algorithms, predict behavior based off of data. Okay? Look at your sales data and look at your customers' address information. And if you're Walmart, understand that these people here in Florida are not going to buy ice scrapers. At least not in Orlando where I'm at. Maybe over in the Panhandle, Tallahassee area every 20 years, maybe. Yes?
I work at U of A, and we're a big analytics shop. We just recently got into Hadoop. We're a big SaaS, a little bit of R right now.
Oh, you have moved to R, because I remember last time we talked, you were definitely in with deep with SAS.
But what's interesting is SaaS you call R programs now. When your SaaS program, And then the second thing I was going to say is the tools they gave us was Hive and Impala. Was it on your slide? My question is, they don't give us a lot of education on that. Like with R, I learned Coursera and EDX.
Yep.
And Black Books from O'Reilly and StackOverflow.com and Google. Okay. What is your recommendation for people who are new to the Hadoop to start their education? Is my question.
Depends on the piece. Okay.
And if they're, say they're analytical, like I am, and like I know SAS has POC to do, and R has a pack to do. Right? Kind of how it works.
For base Hadoop ecosystem products like Hive and Pig, I got started with the Hortonworks Sandbox. The Sandbox is a Linux VM with a web front end, and it walks you through basics of creating Hive tables, selecting from those tables, doing just basics and understanding the differences between the tables. Pig demos for ETLing your data, or ELTing your data. That sort of thing. Because it's an open source product, for the most part, Hadoop, it's a lot of learn on your own. That's just the mentality I found with that with that community. But I can tell you also there's a lot of great resources out there from Microsoft with the part of the Virtual Academy. Now those resources tend to veer more towards HD Insight. But again, they get into some of the basics of, for instance, writing a Pig job, but then also how to submit that job to an HD Insight cluster using PowerShell or .NET if you have the Azure Power Pack. Yep. So once you get your data in there, now what do you do with it? How do you get at it? There's a lot of visualization and analysis tools out there. Excel at its basic can do it. Power Query. How many people are familiar with Power Query? Oh, Power Query is a great tool. It's an add-on, free add-on with Professional Plus Office 2013. Okay? You can if there's a data source, you can hit it with Power Query and pull data. Okay? I can query Azure ML Web Services. I can submit data from a spreadsheet to a web service and pull data out with Power Query. Again, not even close to being a developer. And I called a web service, gave it data, and got data back. That was a pretty cool moment for me. Okay? Power BI. It's the new cloud, your data visualization station, okay, is part of the Azure tools. Power BI is great, gives you opportunities to pull from HD Insight, okay? Also using some Power Query, creating Power Pivot, Power View dashboards and worksheets, things like that. It's a great tool. Data pipelines, okay? How do I get data in, right? Outside of just sitting there and loading files in. Scoop is a great tool to bulk data transfer between your relational databases, your MySQLs, your Oracles, your SQL servers. Scoop allows you to create those pipelines to move data easily in between. Yes, there are SSIS tools. No, I don't always necessarily recommend them. We can talk after the session about that. Flume, collecting and aggregating and moving streaming data. Okay, I've got a lot of developers in here. How many are familiar with Event Hubs? Streaming analytics in Azure. Same basic idea. That's what kind of Flume does. You're going to have it collect data, you're going to have something send it data, and it's going to be able to push it out, okay, in multiple copies, okay? But again, it's like a bulk load on SQL Server Scoop is, so that you're pulling in bulk data and moving it out. SSIS, if you try and use SSIS natively to move data in and out of a cluster, you're going to use ODBC connections most likely. Okay? If you've tried to use an ODBC connection, okay, I've got enough smirks in the room. Everybody knows that's a terrible idea. Okay. Flume is a data streaming service. It's collect, aggregate, move large amounts of data. To a certain extent, Flume has kind of fallen to the side, but it's still a viable tool. Okay? One commonly used way to use Flume is collecting and aggregating Twitter. And then you can pass it into your cluster. I got 7 positive tweets during the 1500 hour of this date. And 50,000 terrible tweets, okay? If you want to do some sentiment analysis. I had 8 people tweet they loved my company, 50,000 say they hate it. Hi, my name is AT&T Mobile. No, I'm just kidding. I'm just kidding. I just pulled out a company. No, I'm just kidding. So like I said, with the Flume, it collects it a lot in the same ways as event hubs. Okay, so you have a web service that you make a call to, pulls it into a source of Flume. That source pushes it into the channel where it travels out to the sink that collects the data from the channel and then dumps it into HDFS. So that you're dumping it into a text file in most cases in HDFS where then you can do further processing on it. But it's a great way to stream in data. Okay? Are there any questions? Because I tried to whiz through, especially the end, a lot of it. Because now it's 1:45 and I want to make sure we have plenty of time for questions because I went through a lot of information there. This is 2 hours of content in my company's Intro to Big Data session, and I squeezed it into 40. So please have questions. Yes, absolutely.
In our company, I think it's about a 30 or 60 times difference the cost to store data in they told us versus we're a big Teradata shop. So my question is, there's a guy named Tom Coughlin.
Okay.
I don't know if you know his name, but he's pretty famous in the Teradata world. He wrote a package, a product, I think it's called Nexus, that you can do queries against multiple relational databases in the same query. That's what you can do. Oracle, Teradata. My question is there something in the works we can do until we get everything converted to do? We have so much data in relational databases that you could run one query, both sources within the same query.
There is a great tool out there, and it's actually part of Microsoft's architecture called an APS, Analytical Processing Server, I believe. So APS runs a specific version of SQL Server, okay? That version of SQL Server is based off of distributed computing like this. It's a MPP, or Massive Parallel Processing version of SQL Server. It also has Polybase and a version of HD Insight. I won't say it has HD Insight. There are some limitations to the APS version, but it has a version of HD Insight so that you can then write one query to query Hadoop or your, what some people, it can query the MPP version of SQL Server, okay, on the APS. So it's one query pulling from 2 spaces. Now, when we've done all this talk about Hadoop and the architecture, well, what am I going to use it for? What problems is this good to solve? I have 100 megs of baseball data from the last, I don't know, 10 years of baseball statistics. That'd be great for it, right? Well, no. You can load it in SQL Server and do a lot of the same work, and might even be able to do it faster or as fast. Is it great for that? Great learning experience. I can't knock it. A lot of my demos I do with the baseball data. It's easy to run some quick processing, some quick queries on when I'm trying to do a demo during an hour session. Wrong problems for big data, okay? I had one client that hit all 4 of these bullet points in one conversation with me. I walked into them, they wanted to move out of cloud virtual machines because they felt they were spending too much on the architecture, and they wanted to look at HD Insight instead of SQL Server. Because it's, all this data was being stored as part of an application, web application they service to the community. It was highly transactive in that it was getting data every minute from some of their clients for their clients' users to access through the application. It was structured data from power meters, and they wanted fast response because it was going to a web app. The web app was going to call out to the Hadoop cluster and get them they wanted the data to come in less than a second because they were at 1.5 seconds on web service calls as it was, and that was too slow. I said to him, I'm like, with Hadoop, 1 second for that call to come back if you were writing the Hive query directly against the cluster, you're winning. You know, with the sheer volume, you're not, that's fast response, structured data, it's not what it does best. Structured data in large sizes, sure. Highly transactive, no. Fast response, no. This is designed to handle business problems that when you put it in SQL Server, you hit execute on the query and go have lunch. I'm not talking hit McDonald's drive-through. Go sit down at a 5-star restaurant and get all 5 courses, okay? Those kind of problems. So when you talk about the right problems, large volume processing, in-depth calculations, predictive analytics and machine learning, all of those things that maybe 10 years ago or 15 and maybe even 20 years ago, talking about these problems in the boardroom and talking about trying to solve them, that's never going to happen. That's these kind of problems are what this was designed for. I mean, you figure Hadoop at its base was the technology that helped Yahoo get off the ground and actually crawl the internet, store data, and be able to answer calls when you searched, I want to find a cheap sporting goods sales website. That's what this was designed for. Industry scenarios. Now, yes, we have to have the boring and we have to have the awesome, okay? The boring, quantitative analysis, social sentiment analysis, you know, looking at Twitter or Facebook data. Manufacturing performance, kind of gets along the lines of the example I gave about windmills. Connected medical devices, so being able to collect data from and actually average it out, query it, run any kind of analysis on medical data from multiple patients at the same time. Some of the cool uses, the Olympics. The Olympics used it in a lot of their Twitter and Facebook data to locate issues during different events. I believe that example was specifically from London. Video games. I did project work for a certain video game manufacturer in the state of Florida. Don't you love how I give examples that are so close that if you know who has an office in the state of Florida, you know exactly where I was at. They actually collected and queried game telemetry data using Hadoop. Now granted, each game team was fairly siloed, so they all kind of used their own storage technology to collect the data, but then they brought it all together in Hadoop, and that's how they accessed the data. So that you had your program managers higher up in, in that specific genre of games that could actually look out there and say, okay, this game is terrible at in-game purchases, they need some work. This game is awesome, they should be an example to everyone. This game has some issues with certain actions always getting a huge successful outcome, that sort of thing. Weather prediction. After search engines, weather prediction was one of the first areas to pick up and run with big data and Hadoop technologies. Collecting and forecasting data. Formula One, taking all of the telemetry data during practices, They were one of the first. They're the more technologically advanced of the race car series. I think we can all agree with that. They were the first ones with digital dashboards and steering wheels. And then it went to Indy. NASCAR just got flashy lights on the dashboard, and they're like, woo! But they're getting there. They're collecting more telemetry data from cars as well. But Formula One actually using it in an actionable way to configure the cars to be less, more aerodynamic, less friction with the air, go faster, optimizing the engines, all of that. So there's a bunch of different ways you can utilize Hadoop. You can basically just pull data into your cluster, process it, kick out results, and visualize it with Excel or Power BI or whatever. You can do it with data warehousing and on demand. So you can pull in very, very granular data, use the cluster to process it, aggregate it, push it into your data warehouse, and then use that with your existing data presentation tools or analysis. Okay? Some clients pulling data out of their data warehouse to make predictions, feeding in that prediction data back in so that then they can show the flow of sales, how they've been going, and then how they forecast the sales to change or go in the future. ETL automation. There's actually some clients that I've talked to that are actually using their source systems they're not necessarily connecting to their source systems with tools like SSIS or whatever. They're kicking out flat files. And the sheer volume of flat files, they're having issues actually processing them all with SSIS. So they actually started looking at big data solutions to kick out the flat files into an HDFS cluster, have it be pulled into there, have the transformation of the data done in there, and then push it into SQL Server or in the Azure SQL database. Okay? And then kick it out through their normal presentation channels. Power BI, Excel, reporting services. Maybe it gets pulled out of one of these databases and there's a sales cube, that sort of thing. This is the future of data warehousing right here. Integration. Just exactly the scenario we were talking about. One query looking at a data warehouse and Hadoop cluster, pulling that together, kicking out the data to the presentation layer. Okay? Spitting data out to different data marts to handle enterprise level where it may not necessarily be possible to have a 5-year history in one data warehouse running on a SQL server. There are even clients looking at, not necessarily my clients unfortunately, but companies out there looking at utilizing Hadoop as their data warehouse. For me, that blows my mind, but if you're into a larger data set, where you just can't get it answered out of a SQL server no matter how many procs, how much RAM you throw at it. This is opening doors for a lot of clients, a lot of companies, okay? Where they're utilizing data marts, they're utilizing some star schemas, and they're utilizing Hadoop, collecting all of that data together and making one data solution, okay? Now, when you talk about companies using data marts on Hadoop, that's where you fall into terms like data lake. How many people have heard that? Okay, when you get done here tonight, go back to your room or wherever and Google, what is it? Don't piss in my data lake. It's not as bad as it sounds. It's actually a really good session. It's by Karen Lopez, and it talks about bad data or bad data stewardship rules that you have in place that can actually create terrible analysis. It is a great session. Karen is better with session titles than I could ever dream to be. So your big data lifecycle, it's small, but when you're doing a big data project, there is a certain life cycle. Yes, I use words like requirements and life cycle. I'm sorry, Agile folks. I do agree with an Agile methodology to a certain extent. Okay? There is some sort of planning that needs to come into play when you're looking at a big data project. You need to look at your business case just like any other. Identify the data you're getting, not just where it is, where it's from, and what's it needed for. Okay? Then how you're going to acquire it. What are you going to do with it? Do you need to transform it? Spit it out. Validation and cleansing of the data, obviously, because you're not going to spit out raw data. If you spit out raw data, you're opening yourself up for issues and acceptance issues from your business users. Okay, how you want to analyze the data. Do you want any predictive analytics, machine learning, that sort of thing? Then you have to obviously visualize the data so that people can validate that you're putting out positive outcomes, or real outcomes and not spitting out garbage. Okay? And then enterprise integration. When companies talk about using big data, they stop at 9. 9 times out of 10. It's a different technology. For instance, I'm a Microsoft guy. I work for a Microsoft partner. They will silo your Hadoop from your SQL Server because in some cases the clients are running Hadoop on Linux. It's a different technology. They build the wall, keep them separate. Don't do that. You're only as smart as the knowledge you have. So how smart of a business decision can you make with half the information? Okay? Just going to click through that because it's a lot of what we already talked about, but it's some of the steps involved. So with initializing, with a cloud solution, you're part of the initialization step is just setting up your cluster. Okay? Getting through that, loading your data, any of your querying, and again, going through all this. It's just a step-by-step. But now when you're using cloud platforms, for instance, like Azure, remove the cluster. It's the most important step you're going to have. How many people remember mechanical gas pumps? That dial would just spin, right? So as you're pumping gas, it's just spinning. HD Insight's the same way. Until you remove the cluster, that dial's just spinning, okay? You're going to keep getting charged, and you can easily kill a free trial of Azure by leaving a cluster on. You can kill it in less than a week, I guarantee. Okay? Like any project process, though, you're always going to go back. Okay? I'm sorry, but with a data project, you're never done. If your data project's done, you did it wrong. Because if you get to the end of your data project and it doesn't raise more questions, you didn't ask the right ones to begin with, or you didn't create the right solution. Okay? Any questions? All right, well, that's all I had. Thank you very much for your time. I'll be back at 3:30 to talk a little bit more about machine learning and analytics. Thank you.